In this section, we're going to learn how we can run Java EE applications in Docker containers. First of all, we're going to see what different options are there, how we can package Java EE applications, and then how to containerize them. We're going to see the challenges that we have to face once we run Java in Docker containers, and also how the Docker copy on write file system works internally and how we can leverage these principles and approaches. The first video is about how we can package Java EE applications. We're going to see what different options are there in terms of deployment, what the difference is between fat and thin deployments, and also briefly how we can run Java EE applications locally. So now we want to introduce the so-called coffee shop project. That is a Java EE application that will be used as an example throughout this video course. And that for now is quite empty. So we have a Java EE 8 API that is included as a dependency here. Here you can see the Maven pump file. And this dependency is provided, which we will explain later on why this is important. And also it is packaged into a WAR file. So here in this project, you can already see a root resource, which for now just returns a hello world coffee response and does nothing else for now. And this will be built into a WAR file. And now this means that this is a so-called thin WAR file approach. So which deployment options do we have? And I mean modern deployment options. So EAR files should not be a question anymore with a modern Java EE. They just don't make sense anymore to package into EAR files. So what we want to have is to minimize a deployment option, minimize a deployment artifact. And there are several options are there. First of all, and best of all, and I will explain why, is a so-called thin WAR file approach. This means we only include and ship our application classes. So the deployment artifact, the thing that will be shipped and deployed to our application container, only contains the classes, only the business logic, ideally, of our application. As opposed to, for example, a fat WAR approach, where we also have a WAR archive that includes the application, but also some libraries or some basic runtime, which is a bad idea for, a couple of reasons. But first of all, let's tackle the other ones as well. We have also a jar file deployment approaches, where basically you have standalone jars. That means your runtime, your application server, the container is also included in this jar file and will be, shipped as well and then start up usually with options and variations from java -jar to run that jar file. There are a couple of different approaches there as well. For example, so-called thin or hollow jars that only contain the application and then have a separate jar file that basically loads a thin jar or sometimes a thin WAR, where the jar file that you actually run contain all the runtime and potential libraries, and then just load a jar file or a WAR file that is then again a thin approach that only contains your application classes. Or a so-called fat jar approach, where you basically put everything, your application, potential libraries, and the whole runtime, including the application container, into an executable jar file and just execute that. So what is the problem with these approaches? Well, we will see later on what principles Docker has in terms of file systems. But for now, the biggest difference is the build size. That means we have our project here that we can build with Maven. So once we issue Maven clean package, then this package everything into our WAR file. The first good message is this runs very fast, even if our project gets big. Why? Because Maven doesn't have to copy a lot of stuff from A to B. It basically only copies and compiles our classes that are part of our application. Everything else is provided and will not be touched by Maven, and we can rely that later on our runtime will contain these libraries. And once we look into the target directory and specifically our WAR file, then we can see that now we only include the classes we just have plus some, Maven built properties and default XMLs to our application. Everything else will be there from the application server. This is good because of a couple of reasons. First of all, the build is fast. Then second, once we want to publish and copy that WAR file to somewhere else, this always will be executed very fast, since it is tiny. It only contains a couple of kilobytes. And even for big projects, you only contain class files, or most of it, which are very small. And why is this important? Well, because everything you're shipping will be shipped very often, ideally. Once you implement continuous delivery approaches and ship and build your software very often, several times a day, several times in hours sometimes, then you deploy and copy all these artifacts many times. You are not copying the runtime and libraries that don't change that often each and every time. You're just copying the things that change, the things that matter, your application each and every time. And these changes are tiny. Therefore, it makes a lot of sense to take this to heart and build thin deployment artifacts, ideally thin WAR files. You could also do thin jar files and load a so-called hollow jar approach. But in the same reason, and we'll show this in a second, it doesn't really make a difference since we're using now Docker containers. So how does this work? For now, we could deploy this locally. So now we have our WAR file here. And then, just as we did for many years, we could have a local installation of an application server and ship that WAR file and deploy it there. That's a basic approach. And still, although this approach is now outdated with Docker containers, we could do so, which would be very fast since we're using thin deployment approaches.